And now we have on the other side of the wire, Vagif Abilov. Hi, Vagif.
Hi.
Hi. Hi. We were just talking with Vagif that it's nice to it's nice when we can meet in person, but build stuff is going quite great. Vagif even said that maybe it's the biggest conference happening in these last few months. Am I right, Vagif? Online conference, not so
well,
many.
That's the biggest one which I've spoken to.
Yeah. Oh, that's cool. Good to hear, and it's all going well. So something to be proud of. So a few words about Vagif before he goes with his presentation. Vagif is a Russian-Norwegian developer working for a Norwegian company called Miles. He has about 3 decades of programming experience. Currently, he's focusing on building systems in F and C, and Vagif is a frequent speaker at software conferences and contributor to some open source projects. You could see him in build stuff last year and the year before, I guess. Yeah, and the talk that Vagif is going to give is called Life After Business Objects, Confessions of a OOP, Object-Oriented Programming Veteran. So Vagif, the mic is, the stage is yours, let's say. The online stage is yours. And as always, all who are viewing this talk, you can ask questions in the chat. And Vagif said he'll have some time to answer it at the end. So Vagif, take it away.
Thank you, Lucas, for introducing me. Yeah, my name is Vagif, and this 40-45 minutes we'll be talking about what does it take to abandon business objects, and especially what does it take for a person who considers himself OP veteran, like myself. And I have some proof that I'm object-oriented veteran. My GitHub nickname is Object. And my Twitter nickname is OOObject, which is because like when I took it, an object was already taken. So it tells something about my affiliation, about my mindset, I guess. And that's correct because I've been doing object-oriented development for about actually for more than 2 decades. At the university I started with, it was long before object-oriented world. It was like Fortran, and it was Pascal, C, and then I switched to C++, and then later I switched to C#, and my change to functional programming in Fsharp, it happened around 2012, 2013. So for more than 2 decades, I've been doing object-oriented development. And I will guide you through motivations, through reasoning for doing that, and also tell a little bit about how do I feel now, what was the change, and what are my current view on being post-object oriented. But one thing I want to make clear, I want to make a disclaimer, because this is not sort of religious talk. This talk is not about presenting the one and only great paradigm, because it's actually it's all about feeling comfortable with how you solve your problems. There was a great blog post by Eric Sink. He's I would say he's software legend. He was one of the people who stand behind first internet browsers, and later he, in his company Source Gear, he developed one of early version control systems, Source Vault. It was before Git conquered the world, and he is using, among other languages, Fsharp, and he wrote a blog post that I think it was like 5-6 years ago, which was called "Why Your Fsharp Evangelism Isn't Working." And he discussing in his blog post pragmatists in pain. Like most of software developers are pragmatic people, because we must work pragmatically to be able to solve our problems efficiently. So we are open for reconsidering things, but we need to feel the pain first. So it doesn't really help to approach somebody who is happy with object-oriented approach in his applications and start telling him, okay, but have you heard about monads? That's a great thing. I mean, just look at this. Now you have to first to find this person in sort of in the right time, and people should by themselves come to this understanding of something can become better, something is not quite right around them. So this is our product. We are media company, and what we do is we upload media files to the cloud, so people can stream media files, TV programs, radio programs, news clips onto various devices. So there will be not much we'll be talking about our product, but it's just to show that it's quite important set of services we are responsible for. So it needs to be reliable, it needs to be fast, it needs to be scalable, and so on. But we will begin with much easier things. Modeling a point. Yes, so that's actually what can be easier. You have a point which consists of like y, x, and y, and then how it can be modeled. A couple of years ago, I watched a talk actually attended this talk by Dmitry Ivanov. At that time, he was at JetBrains. I think he's working for a different company now. The talk was not about functional programming at all. It was about immutable collections in .NET. And but he began with a very simple example about how easy it is to get wrong very simple class. And it was so illustrative, his example, so I asked his permission to use his example in my talk. So this is a class point with x and y, with getter and setter, and it has constructor and has a couple of methods, increase x, increase y. And this is how many software developers or C# developers would have written such class. And the class has 5 lines of implementation, and 4 of them are wrong and 2 of them are missing. And there are 2 missing lines, which are get hash code and equals. So if this is a reference type, so you got to have hash code and equality defined for it. And this class is not thread safe. So and of course we need to take care about our classes being thread safe nowadays. So to make it thread safe, we need to make properties x and y read only, and we also need to make this message increase x and increase y to return new instances of points rather than doing changes in place. So as you see, there are in total 6 lines which we changed. There are that modified lines and there are new lines. This is for comparison how this can be done in Fsharp. So it's equivalent type without the weaknesses of the original implementation, and it just works and it's thread safe. And this is how you can instantiate it. There is a point P and point Q. It copies original values of point P and changes one of the values, one of the properties. So you can say that okay, developer needs to be knowledgeable, developers need to be disciplined, and so they can make design mistakes, and of course they need to solve it. I would say that it's more like insufficient experience, because to get it right, to get things right, using languages like Java and C#, you need actually to have more experience. It's not a bad thing having more experience, but it's actually great to have safe sets of initial defaults. There is a principal differences in initial sets of defaults between OP and functional programming. With object-oriented programming, with its main languages like C#, Java, C++, they empower you through a variety of choices. And with functional programming, it's a different approach. They prevent you from unconscious mistakes. So things are quite different. And not just that, but if you think about that nowadays we all care, we all want our classes, our types to be thread safe. That functional programming actually it's your path to concurrency, which can't be underestimated. You can design great classes, but properly protecting access to them, it's quite manual matter, and locks do not compose. So it's somebody said this, and it's quite important statement that if unlike you can build more complex applications and services from simple components and classes, like by composing them, you can't compose locks in such a way. It's always manual things, and because of that, developers tend to be very conservative about making about locking more than rather than locking less. And then there is a brutal Amdahl's law which comes to action, which actually sets numerical rules about how much of a performance gain you can expect if a certain part of your code cannot be parallelized. And this is just an example. So if 40% of your code can be parallelized, only 40%, then you can increase your number of processes by 10, and you still have performance gain just by 56%. So actually you get stuck pretty quickly with what maximum performance you can gain, and this is if much of your code cannot be parallelized. With functional programming, with immutability of types by default, you don't have such a problem. At least you don't have a problem at that scope. Back to business objects. We started working talking about them, and let's have a look at our point class. So this is class point, which is correct implementation, but it actually lacks something. We can't really use it the way it is now. It is exposed now because we need to have visibility. We need to actually specify visibility for every property and method that should be accessible for client. And of course, yeah, they need to be public in this case. Why public? Especially why public for increase X, increase Y? Because we may have different scenarios, and in some situations we want point to be read-only. In some other situations we want point to be editable, and we don't want to expose editable methods to read-only scenarios. When I started working with OP, I thought that it gives me quite a lot of granularity. Like you have public, you have protected, private methods, and in some languages you also have internal. I don't think it's granular enough anymore, because this is not just a vertical separation. You actually you have horizontal separation by scenarios. So you have a point which has view scenario, which has edit scenario. What should you do? Should you use inheritance? We have point and editable point, and I think I don't need to explain, how terrible would be to design class hierarchies like this. And you probably should then, rather than do that, move methods that change state to a separate class, like point manager. Yeah, that's a way to do it, but this is essentially abandoning point as a business object, because we no longer have properties and methods and operations on data bound by the same type. So in Fsharp and in some other functional programming languages, we use modules as business logic scope. In this very simple example, I chose to give module and type same name. In this case, I sort of expose everything which is in module point also to be available for anyone who uses type point. This is how I can write code that use it. But if I want to control business logic visibility to protect it, I can actually put all dangerous methods, like increase x, increase y, in a different model. I can pack it in different assembly, and the client needs to compile this in this assembly and open the module, and then client will be able to update the point. So business objects. It's a of course, it's a foundation of object-oriented development. It's a holy cow, and it's supposed to show the harmony of data structures and operations on them, defined on the same time, living in peace and friendship and harmony. In majority of projects where I worked with, at least with projects which lasted for more than 2-3 years, the relationship between data types and operations look more like this. This is a painting by famous Russian painter Ilya Repin. So you see that data types on front, and then they need to drag these operations, which actually they don't have any personal interest in them. It's just that they're bound to it for forever. There is a great saying by Joe Armstrong on OP, which said that the functions and data structures are completely different types of animals. So you shouldn't be locking them in the same cage. And when I was switching to functional programming, I was doing it for different reasons. It was mostly like immutability, for example, code compactness. But the more I work with functional languages, the more the more it's clear for myself that like separation between data types and operations, it's a very important thing when you model your domain. There is a book which I recommend you to read, even if you're not into functional programming. It's called Domain Modeling Made Functional. Half of the book, actually, first half of the book doesn't present you any programming language. It just goes you through functional ways of domain modeling. So it's not really Fsharp oriented, even though second half uses Fsharp to show how it can be implemented using Fsharp. And I used same domain which Scott Lushan was using in his book, and that was order processing, and tried to show how I would have done it today if I came back to object-oriented world. So I'm working with order processing, and then we have different scenarios, and this is business pipeline: validated order, then it gets priced, and then we either ship it or cancel it. And we need to design data types and methods for it. So we start with class order, which has some properties, some flags, like whether it's all validated, shipped, or canceled. And then we need to define some method on it. And defining method becomes quickly a very subjective part of design in object-oriented world. Whether this method should be put on the class itself, should be part of order, validate, ship, and cancel, or you can say that no, an order can't validate itself. An order can't ship itself. So let's have an order manager. And this is probably how most of, I would dare saying it, that most of experienced developers, they would probably do it this way, because they learn from the past that doesn't really belong, like ship, cancel. It doesn't really belong to the entity itself, to the data itself. Let's have it part of order manager, order service. Fine approach. But now again, we abandoned object-oriented world, because we have pure data and pure business, like nothing personal. So we are not doing OP anymore. But I wouldn't use just class order, because working with functional programming, we define type for every scenario, and this is how I would do it if I had to write it in C# or Java today. I would never have like just one size fits all order with some nullable values. Small data types containing just data that can be can make sense in this at this stage of business processing. Unvalidated order, validated order, price order, and unfortunately, this is not how majority, I guess, of C# and Java developers design their classes. They, first of all, they often model their classes after the database, which is, this is the worst thing which can be done actually in domain design. Like you model things after your persistent store. And second is because of the ceremony in C# and Java, it's there's always a ceremony associated with defining a class. So there is a habit that a class should be should occupy the whole file. So it's a file per class, even file per enumerator, and and it's kind of like expensive, a class. While in functional programming, like we don't care about how many types we define. It's just we should be as granular as possible with every type definition. It should just cover just scenario where it's used. We have functional transformation, in, out, and a new type for every stage. So this is how would I do it today in C#, and this is how I'm doing it in F#. So I have a small types, it's so-called records in F#, like order details and validated order, priced, shipped, and you see they have slightly different layout, all these records, because they have just the data which makes sense for this stage. I try to avoid anything which can be optional or nullable, and more about it later. And there is a model order processing where we have functions like validate order, price order, ship order, and so on. And the actual business pipeline, this is how we can bind everything together. So we start with unvalidated order, the original details book, and then we validate it, and validate order returns a new type, which is input for price order, which returns a new type, which is input for ship order, which returns a type ship order. So there are no variables. So everything is just a pipe of functional transformations, and this can be designed very declarative and efficient using so-called algebraic data types, which most of modern functional languages support. What are algebraic data types? It's a combination of so-called product types, which correspond to records, structures, classes, as we see now, and discriminated unions, which is the sum types. So you see that we have type funding source, which is either payment card or bank account. So we can use it to calculate if funding source is valid, as you can see it here. And the operation, it's called pattern matching. So we match our source on funding source type, and depending on whether it's payment card or bank account, we make a decision whether funding source is valid. And we can actually make compiler fail. So you get compilation error if you don't cover all cases in pattern matching. So it's very strict in that respect. And in F# supports also so-called active patterns. So while classical, typical discriminated unions, they give you a finite number of choices. You can, by using active patterns, you can categorize things which exist in indefinite number of instances, like even or odd number, and they can pattern match like there are only two values, like even or odd. So you can match by category, and if you, for example, if you skip match on odd, you will get compiler error. I mentioned that we try to avoid optional and null types, nullable types, and when people advocate switching to functional programming, quite often they say that in functional programming you don't have this billion-dollar mistake. You don't have nulls, but instead you have options. You have maybe monads, and I'm afraid that people are probably too often present like optional types as something which is far better than traditional nulls, which is actually not. Because whether you have a nullable type instance which is null, or you have optional type which is none, you actually have a problem in your domain, or potentially have a problem, because you have something missing value and you have to deal with it in your domain, and you should strive to avoid that. There is a great quote by Yaron Minsky. He said it a few years ago in a blog post: "Make illegal state unrepresentable." And I think this quote was repeated in several blog posts and even books, and it's extremely important to follow that. So you should design your type in a way so it's not possible to have an instance of your types which combines values that can't really happen in practice. So option values are fine, and domain boundaries. So when we get things from external services, when we read things from databases, then there is no other way for you just to accept them. But as soon as you have accepted them, you should transfer them into something more tight, which should probably avoid using them as nullable or optional values. For example, if you have a scenario where you accept both unregistered and registered users to do certain actions, so you accept people without names, you may need to split it into different scenarios, like scenario for unregistered users, scenario for registered users, or you may, if names are not used in this scenario, you can make another type actually which don't have name at all. So it's better not to have name at all than to have it optional. I can recommend a fantastic talk by Rich Hickey, creator of Clojure, 2 years old, but still very important and valid for all of us. It's called Maybe Not. So actually, it's a 1-hour talk dedicated to optional types, optional values being harmful. So where he attacks maybe, either options, and here's a picture, actually 2 pictures. This is one of his slides where he shows difference between sets and slots. So sets on the left-hand side, it's you have a set of sheep where sort of you don't have a notion of absence. You just deal with whatever you have. While on the right-hand side, you have a typical record or class with some nullable or optional values which may be empty. So you have to deal with these empty holes, and that makes your logic more complicated and possibly corrupt. And as Rich Hickey says himself, you can judge for yourself which picture looks nicer. But can't we adopt FP style in C#? So that's a very good question, because if you look around at languages which positioned or which used to position themselves as strictly object-oriented, then actually they all make different claims now. Traditional all languages, they become multi-paradigm. So whether you take Java, Kotlin, C# or even C++, they all tell you now that you don't need to write object-oriented code using even C++. But what should you be writing? If you're a C++ user, I'd recommend to watch talk by Phil Nash, OO Considered Harmful, or TPP-Conf, and think about somebody in the mid-90s who would do a talk at C++ conference telling about object-oriented programming being harmful. It was like, it really met like swaying in the church. But yeah, this is a 1 hour talk which actually goes through harmful manner of writing object-oriented style in C++. And what Phil Nash suggests is it's all functional, actually. Prefer mutable value types, persistent data structures, monadic operations, and functionally composable algorithms. So this is how today, even in C++ world, developers are advised to write programs. So to answer that question, can't we adopt FP style and C#, Java, C++? Absolutely. Yeah, you can, and you probably should if you feel being pragmatist and pain doing object-oriented development in object-oriented languages. Absolutely. But I would say that if you go that transition, if you go that path, you should also consider doing it in a plain function languages, because they just better fit. I was preparing this talk, and I thought I had my slides complete, but day before yesterday, I watched reactions on another virtual conference, .Netconf, where Alexey Golub said that he's disappointed that C# is adopting so many functional features from FP, because it's kind of it's messy, because fundamentally it's object-oriented language. And he got a response from Mats Torgersen, and Mats Torgersen, he's one of the principal C# language designers. Actually, he's the one which basically decides, together with some others, what will be scheduled for the next C# release. So he answered that yeah, we have to do certain changes. We have to adopt certain FP features, and C# is getting nicer. You can write more compact code using C#. But that said, this is a quote from Mats Torgersen: if you want the full functional experience, F# is a great choice. And also, to illustrate that, I would remind you that object-oriented programming, the term, was invented by Alan Kay. And he said later that when he invented this term, then he didn't have C++ in mind. And to find out what Alan Kay probably had in mind when he invented this term, object-oriented programming, so actually he thought about objects, this is his word, being like biological cells. So his reasoning was had actually physical processes and physical entities, physical objects in mind. And for him, OP meant messaging, local retention, protection, hiding of state process. So and this reminds very much about actor model. And originally, when I was preparing this talk, I didn't think that I didn't plan to mention akka or actor model, because like transition from OP to FP, you know, this has nothing to do per se with actor model. But then I had a question when I did earlier version of this talk at some other conference, like how do you deal with state? Okay, function transformations are, yeah, it's very nice, but okay, what about state? You need to store state somewhere, and we use actor model. We use akka.net to implement stateful objects. So combination of functional programming and actors to store state and messages to drive business processes. For us, it's a great combination, and this is how we feel we work efficiently. Thank you. So to summarize, impact of F# on feature development cycle. So algebraic types. So we model our domain using algebraic types, and we feel that this gives us much more terse code, and we are more efficient, more illustrative, and as I showed some examples, some of this code actually can be read by non-technical people. Immutability. We have small immutable records for every business scenario, and again, this is a fundamental difference between object-oriented languages. Even if you start writing functionally, they will always have mutable data structures as their initial choice, as the default. Immutability, it was one of the original reasons for us to switch to functional programming, and it's still one of the for us to appreciate that we are doing functional development. This actually, the third, can be applied both to functional style and doing things in object-oriented development. Elimination of nulls, options, they just make your domain tight. But it's just after we have switched to functional programming, we really realized how important it is to achieve. And also, this traditional object-oriented way of declaring visibility, like public, private, protected, it's not good enough for us. We use models to expose right business logic at right place. So that's, of course, we have more things to share, but within this 3/4 of an hour talk, that's probably the biggest lessons that we have learned after switching to functional programming. And also I should add that we shortened the cycle from specification to production. So that's probably the biggest bonus in the eyes of our stakeholders, our management, and of course ourselves. So we definitely experience that we much more efficient in terms of speed of delivery, speed of implementation of new features. We have much more terse code. Typically, yes, we have plenty of tests, but with Fsharp, as like you make some changes and then you spend maybe a couple of hours to make things compile, then it compiles and then it just runs and all tests are green. So with that, actually, I have completed the main part of sort of my talk. And if you have any questions, you can ask them now, or you can contact me on Twitter. My nickname is easy. It's object over object, and you can also write me email. Thank you for listening, and I think I have some time for questions.
Yes, so thank you very much, Vagif. We have a few questions for you at the end of your talk. Some people joined and came on the chat, or should I read it out loud?
Let me see. Okay.
All these short names for technical stuff, I'm afraid I got lost in the middle of it. So can you see the question here?
I see one question from Ivan. Since your name dropped actor model and even Akka, what I thought on Erlang and also on Beam ecosystem, Erlang for Leverage Lisp, Elixir, and so on. I'm asking especially since the integrated actor model level of VM. Yes, I think that if you want to build, if you sort of in love with actor model, if I may say that, then using Erlang and Elixir is sort of native way to write your applications, and it's often you need to also to address other concerns, like what languages can organization adopt. We actually had the same concern when we were adopting Fsharp, because even though we are sort of part of our development doing .NET development, so it was like precondition, like we should do it in .NET. But in the beginning, in like the first years, it was like, okay, where do we have enough Fsharp people? We don't think that way anymore. I think anyone can learn any language, basically, relatively short time. Attitude is more important, but absolutely, Elixir and Erlang is definitely right languages to use with active model. And you have products like RabbitMQ, you have products like WhatsApp. So it's proven, yeah, and it's scaled to hundreds of million people.
Great. So a few more questions. First of all, some kind words, not questions. So David Ostrovsky is saying, very interesting talk, Vagif, nicely done. So that's something.
Thank you, David.
And this is Danny de Klerk. He's also saying this was a rockstar talk. So happy I finally had a chance, by the way.
Thank you. But also he has a question, I see. When
yes, a question too.
FP, I think he meant probably FP, functional programming, and when definitely use OP. Definitely. It's hard to say, really. Because when people started using language like Fsharp, I remember like 10 years ago, you send an abstract to international conference proposing Fsharp talk, and you get accepted immediately because oh wow, there is somebody who does things in Fsharp. Oh wow, that's really cool, interesting. And then after it's okay, questions, okay, fine, but do you really use it in production? And the speaker would tell you, no, I don't really production. Nobody using it in production, but like we have plans and problems. So it's and I think this attitude continued for some time. Like Fsharp, it's for financial computations. It's like for science and so on. But I don't think there is a strict distinction between where you can apply Fsharp or like functional languages, or where you should use object oriented languages. We use Fsharp for everything. A few years ago, I would be skeptical, like using Fsharp in front end, but then I learned a little bit of Elm, which is it's Fsharp looking, like both Fsharp and Elm, they ML type of languages, and Elm is language specifically built for writing user interface web applications. It's a great language, and inspired by Elm, Fsharp now has a framework called Fable, which actually we use Fable. I didn't mention, but we use Fable internally to build some internal web applications. So actually, we write Fsharp front end, which compiles into JavaScript, and it's working nicely. So I say that it's not more decided by the field you apply your language. It's more up to you. What is sort of platform or paradigm of your choice, and you can apply both functional and OP languages there.
So thank you, Vagif. I guess there are no more questions, only some more nice words for you. So Jason Thomas is saying, great seeing you again, Vagif. I have warm memories of chatting with you in Chernobyl at Build Stuff 2016. Oh,
yes,
such a long time ago.
I remember. It's like a different world, and also Chernobyl. It's a bit like a different planet. We went there before it became like known to the rest of to everyone in the world because of the series. That was a great time, and thank you, Jason.
Yeah. So Vagif, I hope that we can see each other again at Vilnius next year. Hopefully,
I really hope so.
Okay. Hopefully, if we have to meet online, we'll do that. But it would be nice to meet face to face, and I see that you have quite a lot of people who follow you, who are really interested in what you have to say. So thanks a lot, Vagif. Thank you for your talk.
Thank you for having me.
See you in the other rooms. I know you're following the conversation. So.